This is SpaceTime Series 24, Episode 84. Coming up on SpaceTime, claims the Toba Volcanic Eruption disrupted climate but not human evolution. Why Comet Halley turned out to be such a dumper in 1986. And Virgin launches its second space mission this month, blasting its Launcher 1 rocket into orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims the biggest volcanic eruption in human history, Indonesia's Toba eruption 74,000 years ago, likely caused severe climate disruption but didn't affect human evolution as much as thought. Previous studies have suggested that this massive eruption may have reduced Homo sapien populations down to just a few thousand breeding pairs, triggering the species' migration out of Africa. But the new findings, reported in the Journal of Proceedings of the National Academy of Sciences (PNAS), claims early human populations would have been sheltered from the worst effects of the blast. The Toba volcano was the largest volcanic eruption in the past 2 million years. The study's lead author, Benjamin Black from Rutgers University, New Brunswick, claims past climate modelling has suggested that climate consequences of the Toba eruption would have been severe. But archaeological and paleoclimate records from Africa don't show such a dramatic response. Resolving this paradox is important for understanding environmental changes during a key interval in human evolution. The results suggest that scientists may not have been looking in the right place in order to see the climatic response. Black says Africa and India were relatively sheltered, whereas North America, Europe and Asia would have borne the brunt of the cooling. One intriguing aspect of this is that Neanderthals and Denisovans were living in Europe and Asia at that time. And the authors suggest that evaluating the effects of the Toba eruption on those populations could merit further investigation. The authors analysed 42 global climate model simulations, in which they varied the magnitude and sulfur emissions of the eruption, the time of year the eruption occurred, the background climate state, and the sulfur injection altitude, in order to assess a range of possible climate disruptions from the Toba eruption. By using this approach, Black and colleagues tried to understand the likelihood that some regions were less impacted by Toba, considering the wide range of estimates for its size and timing, in addition to a lack of knowledge about the true underlying climatic state. And the results suggest that there was likely significant regional variation in climate impacts. The simulations predicted cooling in the northern hemisphere of at least 4 degrees Celsius, but with cooling in some regional areas being as high as 10 degrees Celsius, depending on the model parameters. By contrast, even under the most severe eruption conditions, cooling in the southern hemisphere, including regions populated by early Homo sapiens, were unlikely to exceed 4 degrees Celsius, although some regions in southern Africa and India may have seen decreases in precipitation at the highest sulfur emission levels. The new results explain independent archaeological evidence suggesting that the Toba eruption only ever had a modest effect on the development of the hominid species in Africa. Scientists use a scale known as the Volcanic Explosivity Index, or VEI, to provide a relative measurement of the explosiveness of a volcanic eruption. The largest eruptions to date have had a VEI of 8. The eruption of the Tambora volcano in Indonesia in 1815 ranked as 7 on the VEI scale, making it the largest eruption in modern history. Mount Pinatubo on the Philippine island of Luzon erupted in 1991, killing hundreds of people. It's considered to be the second largest volcanic eruption in the 20th century, with a VEI of 6. Now that's equivalent to 200 megatons of TNT, or about 13,000 times more powerful than the atomic bomb dropped on Hiroshima to help bring an end to World War II. Pinatubo was about the same size as the 1883 eruption of Krakatoa in the Sunda Strait between the Indonesian islands of Java and Sumatra. That eruption culminated in a series of massive explosions and tsunamis which destroyed most of the island, leaving a giant caldera and killing almost 37,000 people. In fact, the eruption blast was so loud it was heard thousands of kilometres away in Central Australia and is said to have been the loudest noise ever heard by humans. Certainly the most famous eruption in modern times was the 1980 eruption of Mount St. Helens in the US state of Washington. It sent a cloud of gas and ash over 24 kilometers into the air. It melted glaciers, creating volcanic mudslides known as lahars. It produced massive pyroclastic flows, destroying everything in their path, and it blew away the entire left side of the mountain. However, Mount St. Helens only rated a VEI of 4. Now, by comparison to these, the Toba eruption 74,000 years ago reached the very top of the VEI scale, 8, and was the largest known eruption on Earth in the last 25 million years. This is SpaceTime. Still to come, why Halley's Comet was a dumper in 1986, and Virgin Orbit flies its Launcher One rocket. All that and more still to come on SpaceTime. Well, it was billed as being an astronomical spectacular. But for most people, Comet Halley's 1986 visit to the inner solar system simply failed to live up to all expectations. Comet P1 Halle is a well-known short-period comet which visits the inner solar system every 75 to 76 years. The 15-kilometre wide mountain of rock and ice will make its next close-up appearance in 2061. The comet's named in honour of British astronomer Edmund Halley, who in 1705, after examining Chinese, Babylonian, medieval European records, successfully predicted its return in 1758. However, Halley himself died in 1742 before his prediction could be confirmed. The comet's highly elliptical and elongated orbit takes it from between the orbits of Mercury and Venus out to almost as far as the orbit of Pluto. Also, Halley's orbit is retrograde, meaning it orbits the Sun in the opposite direction of the planets, that is clockwise as seen from above the Sun's northern pole. That retrograde orbit results in it having one of the highest velocities relative to the Earth of any object in the solar system, some 70.56 kilometers per second, or if you prefer, 254,016 kilometers an hour. Planet Earth passes through a debris trail left behind by Halley's comet twice every year, producing the annual Eta-Aquarids meteor shower in May and the Orionids meteor shower in October. Astronomers think Comet Halley was originally a long-period comet which took thousands of years to travel to the inner solar system from the Oort cloud. But it was later gravitationally perturbed into its current orbit by close encounters with the giant outer planets. The annual Eta-Aquarids meteor shower runs from around the 19th of April through to May the 28th, peaking around May the 5th, with around 55 meteors an hour, making it one of the Southern Hemisphere's best celestial shows. However, back in 1975, they were running at around 95 meteors an hour, and in 1980 it was up to 110. Even better, the bright yellow meteors often appear as streaks known as trains. Somewhat less spectacular, but still worth looking out for, are the Orionids, which appear in late October. They can produce up to 20 meteors an hour, radiating out of the constellation Orion. But while its meteor showers are worth staying up for, Comet Halley itself, when it made its last appearance in 1986, turned out to be a real flop for most people. Jonathan Nally, the editor of Australian Sky and Telescope magazine, says the comet's 1986 appearance in the inner solar system was never going to be the astronomical spectacular most people were expecting.
Yeah, Halley's Comet. Now, did you see Halley's Comet 1986, Stuart? Do you remember that?
I was looking for it. I was standing on top of Bulli Pass having a look for it over the eastern escarpment of the Great Dividing Range, and I saw absolutely nothing special.
Lots of people were disappointed by Halley's Comet, or Comet Halley, as you probably should really call it, official way of saying it. Back in 1985-86, I thought it was magnificent because I knew what to expect. People had, I think, incorrect expectations, and that's not their fault because it really was talked up. Even if it is going to be a really good comet, people who don't know astronomy don't really know what to expect. I think some people think they're going to see something flashing across the sky or some sort of fireworks display or something. They don't really know what
I expect to see something with a long tail. Or two tails. That's what I expect.
Yeah, well, there have been comets in the last 20 years or so that have been really quite spectacular. Comet McNaught and Akataki and Hale-Bopp. Yeah, there have been some really good ones. But let's discuss this then. Why wasn't Halley good in 1986, whereas all the reports were back in 1910 that it was really spectacular? It really comes down to two things. One is that the way things work is you've got Halley's Comet orbiting the Sun and you've got Earth orbiting the Sun. And Halley's Comet comes around every 76 years. But Earth and the Comet are not going to be in exactly the same spot and the same orientation each time. It's going to be different each time, right?
Yep.
Because our year and Halley's Comet orbit don't line up, if you see what I mean. So what happened in 86 was that the Comet, when it was at its closest to the Earth, which is when you would expect it to look its best, because when it's closer it's going to be brighter and appear bigger and everything, at its closest it was 2 times further away than it was in 1910, okay, which means it's going to be 4 times dimmer. So that was working against it. The other thing too was that in 1910 the geometry worked out such that we were seeing the comet pretty much side on at its best.
Lots of pretty tail.
Saw the tail, yeah. Well, in 1986, when the comet was closest to us, and it was still twice as far as it was in 1910, we were more or less looking head on. So the tail was streaming away from us. Yeah. So people in the know knew that this wasn't going to be the best apparition of this comet. In fact, some people said this is the worst one for 2,000 years. But look, don't despair if you're young enough, and I'm not, but if you, listener, are young enough and you expect to be around in 2061, then the conditions then should be much better. I'll speak for yourself. You expect how old you be?
You almost gave it away then, didn't you?
I know. I'm going to be. I would be
over 21, yes.
Very old in 2061. I do not expect to be around in 2061 unless I don't know, they take my brain out and put it in a robot or something. But anyway, look, I got to see it in 86. So, but yeah, anyone who's young enough will get to see it in 2061, and it will be better then than it was in 1986. So yeah, look, I remember seeing it the first time I spotted it. I was in the middle of a paddock out in sort of middle of New South Wales, and with my binoculars. And it was my birthday, and right. I looked up into the sky, and I knew where to look for it, and I put the binoculars up, and I thought, there it is. And it just looks like a little fuzzy ball. At that stage, it was still coming in towards the sun at that stage, late 1985. So it just looked like a little fuzzy ball, but that's what comets generally look like. You know, they don't always have a tail. And then I continued to watch it as the months passed, and I used to work night shift sometimes in the job I was doing then, and I would go out onto the fire escape outside the back of the building and looking over the lights of an oil refinery, believe it or not. I wasn't working at an oil refinery, but there was one nearby.
Oh, I know where you were working with.
I could even see it. In the sky there. Again, just as a little tiny fuzzy ball, but it was certainly there. And I was lucky enough to go on a cruise in the South Pacific around about the time the comet was at its best. And you would expect that you would get a better view of the comet from a ship out in the middle of the ocean where it's nice and dark than you would looking over the lights of an oil refinery. But actually, it wasn't as great at sea as I thought it would be. It was good, but it certainly wasn't as great. 2 reasons for that. I did my viewing with a bunch of passengers up on the top deck of this, right on the top deck of this cruise ship, and the wind and the sea spray and everything. There's a lot of sea spray. Yeah, a lot of sea spray is just gets picked up, and you don't really notice it during the day because everything's bright and lovely. But at night time, that sea spray forms almost like a bit of a very, very, very thin fog, and it just diminishes the light of the stars a little bit, just ruins the viewing or the transparency of the air. And the other thing was, just couldn't convince the captain to turn the lights off because he was worried about safety, of course.
Well, so he turned some lights off. Like that can be,
not all the rest. So yeah, there were a few lights up there, but anyway, still got a good view. But I know that a lot of people were disappointed, and I apologise on behalf of all astronomers that you were misled into thinking you were going to see fireworks or something flashing across the sky, or even something with just a big long tail. But if you saw it, please be pleased, because if you're of a certain age, you're not going to see it again. Most people who live what is now an average life expectancy, at least in the major developed countries, will at least get to see it once in their lifetime. So if they're born, say, 40 years before the comet comes around, they'll see it when they're roughly 40. And if they live to 80, well, they won't see the next one. But if you're born in the year of the comet, or close to the year of the comet, there you might see it twice. The other thing too, I should mention regarding the difference between 1910 and 1986, because I remember there's a lot of stuff in the news about it. You had little old ladies and people saying, "Oh yeah, I remember the comet 1910. It was really, really specky. It was really great and everything." Thing is, there was another comet in 1910. And it was better than Halley. It was even bigger and brighter than Halley was in 1910. And I have a suspicion that some people were recalling that comet rather than Halley. But certainly Halley was better in 1910 than 1986. But, I've missed eclipses. I've missed transits of planets because of weather, that kind of thing. You can't really do much about those events that happen on just one day or just for a few minutes or just for an hour or something. You can travel to the other side of the world to try and see an eclipse, and if it's cloudy, well, that's it. With a comet like Halley, you're going to get several months' worth of viewing, probably 6 months' worth of viewing if you use a telescope. So even though it might not be as spectacular as you think it is a once-in-a-lifetime event for most people. So if you get the chance, this next one comes around, 2061, put it in your calendar now, make a diary note, please go out and have a look.
And of course, the history associated with Halley's Comet is so important as well, isn't it? Because this was how we really started to understand what comets really were.
Sir Edmund Halley, he worked out that this comet that had been seen had orbital similarities to comets that had been seen before. And he twigged that it's probably the same comet coming back time and time again. That was the first time anyone had thought this might happen. So he predicted that it would return again in a certain year. Now, he didn't live to see that, but sure enough, the comet turned up in that year. And until recently, when you now have these automated observatories discovering comets all the time, and you've got
SOHO and things like that.
You've got spacecraft that are monitoring the sun, and sometimes comets appear in the pictures when they get very close to the sun, these little tiny comets. So until recently, where comets are being named after not people, they're being named after machines. Until recently, there were only two or three comets that were named after someone who hadn't discovered the comet. Because if you go out and discover a comet tonight and no one else spots it, you're the first person to report it, it'll be named Comet Gary, right? Or Comet Halley. So typically, the discoverer is the person or persons after whom it is named. They usually have a maximum of 3. But Halley did not discover this comet. He only worked out that this particular comet was going to come back again. But they named that comet after him. So I think it was the first occasion where a comet was ever named after someone who didn't discover the actual comet.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is SpaceTime. Still to come. Virgin Orbit has flown its second space mission of the month, placing several small satellites into orbit. And later in the science report, growing levels of harmful antibiotic-resistant bacteria found in livestock. All that and more still to come on SpaceTime. Virgin Orbit has launched its second space mission this year, placing 7 small satellites into orbit. The spacecraft were carried aboard Virgin's Launcher 1 rocket, which was drop-launched from a specially modified Boeing 747-400 airliner over the Pacific Ocean. The modified jumbo jet, called Cosmic Girl, had taken off an hour earlier from the Mojave Air and Spaceport north of Los Angeles.
Orbit base Halley 1, we're on the takeoff roll.
Orbit base copies, and takeoff roll.
All right, everyone, we heard that we were just about to take off. We have made it to the top of the runway, and Cosmic Girl is moving. And yes, we are wheels up. As a reminder, we're flying out to the Pacific to our drop point, which is 50 miles south of the Channel Islands. Right now, Mission Control is monitoring the rocket to ensure all of our systems are healthy through this takeoff, through this flight. In particular, we're keeping a really close eye on temperatures to make sure the mission is still running on time. We want to still make sure that our liquid oxygen is as cold as possible for our mission. Our LEs, Bryce Schaefer and Jason Panzerino, are doing all of this monitoring work from the aircraft. They're effectively working as a mobile mission control for the rest of the mission.
Altitude 5,000.
Orbit base, Cosmic Girl 01 is over water.
Orbit base copies, over water.
This is LD on control room. We're getting ready to approach the cold pass and are about 3 minutes away from the start of terminal count. I can confirm that AFSS is green at the cold pass. If you have any additional issues, please bring them up at this time.
Cold pass.
Orbit base Halley 2, AFSS is green at the drop point.
Orbit base copies, AFSS green at drop.
We just got confirmation of being green at our drop point. This means that we're ready to go and we're making the turn out and we'll be entering into our terminal count.
Terminal count auto sequence initiated.
Orbit base copies, confirmed terminal count has been initiated.
Orbit base LE2, we've had a momentary warning on S1 DPFTNK. Please advise it's kind of been riding the balance throughout the whole flight.
Orbit base Newton 3.1 has begun chilling.
Newton 3.1 engine chill has begun. Orbit base copies, Newton 3 chill and beginning.
We just heard that Newton 3.1, the first stage engine, is beginning its engine chill-in. The plane will continue its bank and then start going into its hot pass, where we'll be quickly handing off to the pilots and entering into the pull-up maneuver.
S2 tanks are at initial pressure.
SMA on control, AFSS is green on the inbound turn as expected. Copy, AFSS green.
Newton 3 engine chill nominal and S1 tanks at expected pressures.
Newton 3 engine chill nominal and S1 tanks at expected pressures.
TM stations have recovered. Both Long Beach and Mojave have solid lock and solid signal.
Cosmic Girl over base confirms solid lock on S-band.
Copy, solid lock.
Radiohead, please be ready to switch from Panasonic to S-band data in the MCC once the release call is over. Plane Honeywell.
Radiohead, rogers that.
We have confirmation that we've gone to internal power on the rocket. We are now in the hot pass and will be accelerating into the pull-up maneuver.
Cosmic Girl, accelerating to 0.85.
Aircraft S-band and AFSS confirmed go.
Good to proceed with launch.
Oh. Release. Release confirmed.
Release has been confirmed.
PST's ignited.
Newton 3 startup confirmed.
TM source switch to S-band.
Max Alpha flight complete.
We've had successful PST ignition, engines start, pitch up, and have passed max Q.
Cosmic Girl orbit base.
Stage 1 burn nominal.
Verified stage 1 burn is nominal. Max Q Alpha is complete.
Queuing up tubular bells, part 1.
Max Q Alpha achieved.
Stage 1 burn nominal.
The Launcher 1 rocket was carried to drop altitude, mounted on a hard point located next to the fuselage on the underside of the port wing of the aircraft. This hardpoint is fitted to all Boeing 747s and is normally used by airlines to ferry spare jet engines. The 21-metre-long Launch 1 rocket was released at 37,000 feet or 11 kilometres, lighting up its main Newton 3 engine seconds later to begin its journey towards orbit. The rocket's liquid-fueled first stage burns for about 3 minutes. The liquid-fueled Newton 4 second stage engine then fires up and carries the 300-kilogram payload for a further 6 minutes in order to reach low Earth orbit. On this mission, the upper stage undertook a second engine burn to circularize the orbit before deploying the satellites. On board were 4 small national security spacecraft for the US Department of Defense, 2 Stork Earth observation satellites for Polish-based company Sat Revolution, and Brick 2, the first small satellite for the Royal Netherlands Air Force, which will provide military communications and navigation. Last month, Cosmic Girl launched a Pegasus rocket carrying a rapid deployment payload for the US Space Force. That was flown from the Vandenberg Air Force Base in California. Cosmic Girl's first Launcher 1 mission of the year took place in January. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that the Delta variant of the COVID-19 coronavirus can escape neutralization in patients who have only been partially vaccinated or those who've had a previous COVID infection. The findings, reported in the journal Nature, found getting that second jab of the vaccine is crucial to achieving full COVID protection. The authors were able to isolate antibodies from the blood of people who have been infected with the SARS-CoV-2 virus or those who've received only a single dose of the Pfizer or AstraZeneca vaccines. These samples were then tested against various mutations of the virus, including the Alpha, Beta and Delta variants. And they found that some antibodies were unable to bind to the spike protein of the Delta variant, which meant they couldn't neutralize the virus. The results suggest that the Delta variant manages to somehow escape antibodies that target certain parts of the protein. However, the authors found that a second dose of either the Pfizer or AstraZeneca vaccine was successful at generating a neutralizing response in 95% of individuals. The World Health Organization now estimates over 8 million people have been killed by the COVID-19 coronavirus. That includes over 4.1 million confirmed fatalities and some 190 million people infected since the deadly disease first spread out of Wuhan, China. A new study shows that the global cryosphere, the parts of the planet covered by ice and snow, has shrunken by about 87,000 square kilometres, an area the size of Lake Superior, every year since 1979. The findings, reported in the journal Earth's Future, show shrinkage mainly occurred in the Northern Hemisphere, with a loss of about 102,000 square kilometres, about half the size of the state of Kansas, taking place each year. However, these losses were offset by a slight growth in the southern hemisphere, where the cryosphere has been expanding by about 14,000 square kilometres annually, primarily in sea ice around the Ross Sea in Antarctica. That's due to increasing amounts of cold meltwater runoff from the Antarctic ice sheets. The cryosphere is one of the planet's most sensitive climatic indicators because changes in ice and snow cover alter air temperatures, change sea levels, and affect ocean currents globally. And the amount of Earth's surface covered by snow and ice is important because its bright white surface reflects sunlight, effectively cooling the planet. A series of reports in the journal Science are focusing on the growing problem of plastic pollution. Plastics mistakenly consumed as food by fish, birds, reptiles and mammals are causing millions of deaths every year. And microplastic particles are absorbed through the human skin and have been detected in people's bloodstreams. One of the new studies in Science shows that microplastics will continue floating on the ocean's surface on average for as long as several years, harming marine organisms before finally breaking down and degrading. Meanwhile, another study has found that those early bioplastics, that is, plastics made from bio-based feedstocks like corn, sugar and wood, were neither clean nor green. Scientists are now calling for a binding global agreement to address plastic pollution. The move has already been supported by 79 governments. It proposes minimising plastics production and consumption in order to facilitate the elimination of plastic pollution in the environment. Scientists using a new CRISPR-based technique have found growing levels of harmful antibiotic-resistant bacteria in livestock which have been missed by traditional testing methods. The new findings by the University of Georgia and reported in the journal Antimicrobial Agents and Chemotherapy found that 60% of cattle samples contain multiple strains of antibiotic-resistant salmonella. The new testing method, called CRISPR-Seq, enables researchers to analyse all the types of salmonella present in a given sample. Traditional methods only examined 1 or 2 colonies of bacteria, potentially missing some strains altogether. The new technology identifies molecular signatures in salmonella's CRISPR regions, a specialised part of the bacteria's DNA. Traditional culturing methods miss the antibiotic strain in the original samples. Well, as we've all seen over the last few years, bad journalism is now mainstream, ignoring facts and covering up the truth in order to deliberately push a particular point of view. And once great news organisations like the BBC, CNN and Australia's once great ABC are all guilty of it. But now there's something else we can blame on bad journalism: the continuing sightings of flying saucers. Tim Mendham from Australian Skeptics says it seems lazy journalists are happy promoting sightings which lack definitive evidence rather than properly investigating such claims.
It's a vexed thing. I mean, sort of the UFO sightings goes up and down from year to year, and some years they have very, very bad or very low numbers of sightings. Other years they tend to get excited about a particular thing, and it generally is in response to something which is in the news. And recently we've had this UFO that the US Navy supposedly filmed that sort of moves along the surface of the water and then suddenly disappears, and they reckon there was a splash. They went underwater. It's not clear what this thing is. It's just a black blob. There's not a clear shape to it or anything like that. And because this was released or leaked, as some of the news reports say, very recently, we're still sort of trying to work out what it might be. Some years ago, there was film taken by US Navy from aircraft and had white dots and white spots in their sights, and that has generally been discounted as sort of natural phenomena and partially the effect of the gimbals on the filming mechanisms that they have. That makes it look like it's shifting around, but it's actually not. It's more the plane moving and the gimbal sort of adjusting for that. But what happens is, as I say, because if there's more news stories happening around, then you'll see more UFO sightings, which means you have more news and you get more UFO sightings. There's a bit of a symbiotic relationship. And that is a suggestion of an article that was recently put out saying that UFO will never go away as long as the media are so credulous or lazy that they won't look at alternative suggestions. And by and large, most coverage of UFO sightings and ghosts and that sort of stuff is pretty lacking in research. And if that continues, then UFO phenomenon will never go away, because no matter what sort of lousy example you see of a particular UFO or a ghost, etc., if the media just say, here's a fascinating clip, because they have a clip of it, that what you call the falling chimney syndrome, chimneys get blown up all the time, but you have a photograph or a film of one, it becomes news. So if they have film of videos of ghosts and UFOs and things, the newspapers will, not the newspapers, the TV especially, will run it because they need visuals and it fills time. and they'll often just run and say, well, what do you think?
Well, you know people are going to watch it, let's be honest. People are going to sit there and they're going to watch that. Yeah.
I get items sent to me every day of UFO sightings and ghost sightings and things, and quite frankly, 99% of them, of the films, are just really dull. Some of them are obvious hoaxes. Some of them are just so vague you really can't tell anything in them, and most of them are really unimpressive. The occasional one is sort of interesting, and you think, oh, that'd be worth investigating. But in most cases, that are obvious hoaxes. A chair moves, and it's pretty obvious by the way it moves, it's being pulled by strings. Others are so vague, and so sort of amorphous blobs become ghosts, or amorphous blobs become a UFO. And the old story is, if I don't know what it is, therefore it must be a ghost, or it must be a UFO, rather than say, if I don't know what it is, I don't know what it is. And you have to leave it at that until you do some further research. But the media like to jump. Someone says he filmed a UFO, they run the film, and they say, he filmed a UFO. And the lack of discernment, if you like, of the media is what is blamed for a lot of the continuing interest and belief in UFOs. Not the evidence, because there isn't any. There's no hard and fast evidence for these things. There are poor videos and some interesting anecdotes, but there's no hard evidence for UFOs or for ghosts, but that doesn't stop the media from promoting them.
UFOs are real. It's just the question of what they are. That's the issue.
Alien-directed craft.
Oh, I like that, yes.
Okay. I know. UFOs, unidentified flying object, could be a seagull, I don't know what it is, right? Unidentified aerial phenomena could be a cloud formation, but I don't know what it is.
Venus.
But you have to sort of think, therefore say, let's just say flying saucers.
Yeah.
And then we know what we're talking about.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.